In this video, we're going to take a look at how to calculate arc length. In the first example, we have y is equal to x to the fifth over 10 plus 1 over 6x cubed. And we're going to look at this arc length from 1 to 2. So the formula, when we have y is equal to, is going to be L is equal to the integral from a to b of the square root 1 plus f prime of x squared dx. So what I like to do is I like to calculate 1 plus f prime of x squared and then plug everything in. So the first thing that I'm going to do is find f prime of x. So f prime of x is equal to 5 x to the fourth over 10. And remember, we can rewrite 1 over 6x cubed as 1/6 x to the negative 3. So I have minus 3 over 6 x to the negative fourth. And now I'm going to simplify this, so I can say that I have 5 divided by 10 is 1/2, so x to the fourth over 2 minus 3 over 6 is also 1/2, so we have 1 over 2x to the fourth. And now the next thing I'm going to do is square this, so I have f prime of x squared, and that is equal to x to the fourth over 2 times x to the fourth over 2 is x to the eighth over 4. And then we have x to the fourth over 2 times negative 1 over 2x to the fourth, which is minus x to the fourth divided by 4x to the fourth. And then we have negative 1 over 2x to the fourth times x to the fourth over 2, which again is minus x to the fourth over 4x to the fourth. And then we have negative 1 over 2x to the fourth times negative 1 over 2x to the fourth is going to give us positive 1 over 4x to the eighth. And now when we simplify this, we get x to the eighth over 4. And now for both of our center terms, we have x to the 4 over x to the 4. So we're just going to be left with 1/4. So we have minus 1/2 plus 1 over 4x to the eighth. And now I want to add 1 to it, so I have 1 plus f prime of x squared. And when we add 1 to this, it's going to make our center term positive 1/2 instead of negative 1/2. So I have x to the eighth over 4 plus 1/2 plus 1 over 4x to the eighth. And now I want to rewrite this, because this is also equal to x to the fourth over 2 plus 1 over 2x to the fourth, all squared. So what we just found is 1 plus f prime of x squared. If we look back at our original formula, it's the whole inside that we just found. We just found all of this. So I'm going to rewrite this whole problem now, and I'm going to plug that in for underneath the square root. So I have L is equal to the integral from a to b, which was from 1 to 2, of the square root of x to the fourth divided by 2 plus 1 over 2x to the fourth, all squared, dx. And now the square and the square root cancel each other out, and we're left with L is equal to the integral from 1 to 2 of x to the fourth over 2 plus 1/2 x to the negative 4 dx. And I write it with the negative exponent so that we can take the integral using the power rule. And that is equal to x to the fifth over 10 plus x to the negative 3 divided by negative 6 evaluated from 1 to 2. And now I'm going to rewrite it with positive exponents so it's easier to evaluate. So I have x to the fifth over 10 minus 1 over 6x cubed evaluated from 2 to 1. And now I have 2 to the fifth is 32. So I have 32 over 10 minus 1 over 2 cubed is 8 times 6 is 48 minus 1/10 minus 1/6. And when we put all this in our calculator, we get 779 over 240. In my next example, we have x is equal to 1/3 times y squared plus 2 raised to the 3/2 from 0 to 4. And the only difference between this problem and the last problem is now because we have an x is equal to, we're going to have L equal to the integral from c to d of the square root of 1 plus f prime of y squared dy. So again, the same thing that I did last time. I'm going to work on underneath the square root and then I'm going to add everything into the formula. So f prime of y is equal to 3/2 times 1/3 is 1/2 y squared plus 2 to the 1/2 times 2y, and we can simplify that to y times y squared plus 2 to the 1/2, and now we need to square it, so f prime of y squared is equal to y squared times y squared plus 2, and now we want to add 1 to that. So now we want to find 1 plus f prime of y squared, and that is equal to 1 plus, I'm going to multiply the y squared through the parentheses, so I have y to the fourth and 2y squared. So I'm going to write 2y squared plus y to the fourth. And now I'm going to try and write this as a perfect square. So I have y squared plus 1 squared. And now I'm going to write everything into the formula. So L is equal to the integral from 0 to 4 of the square root of y squared plus 1 squared dy, and that is equal to the integral from 0 to 4 of y squared plus 1 dy. And now I'm going to integrate. So we have y cubed over 3 plus y evaluated from 0 to 4. And when we evaluate, we have 4 cubed, which is 64. 64 divided by 3 plus 4 minus 0, because when we plug 0 in for y cubed and y, we get 0. So our arc length here, 76 divided by 3. And that's our video on arc length and how to use it when you have dy or dx.